Docker is not a negotiable skill in this day and age. Let's be real for a second. If you're doing literally anything in tech right now, whether you're working in QA, handling cybersecurity, or even building the absolute latest AI tools, you absolutely need to know how to use Docker. It's not a nice to have anymore. It is a fundamental requirement. Let's dive into why.
Welcome to this explainer. Today, we're going to take this incredibly powerful and honestly, sometimes intimidating technical concept, and we're going to break it all the way down. We're stepping completely away from the dense jargon, and we're going to use super simple, everyday analogies. Trust me, by the end of this, Docker is going to click for you instantly. Okay, let's get into it.
Here is our game plan for today. We've got a clear 5-step roadmap. First, the dependency nightmare. Second, the shipping container solution. Third, images versus containers. Fourth, Docker's CI/CD superpower. And finally, number 5, navigating port mapping. All right, starting with section 1, the dependency nightmare, and specifically server conflicts. If you've been around the tech block, you have definitely heard the classic developer excuse. Well, it works on my machine, right? It's kind of a joke, but it perfectly highlights this massive infrastructure headache. Imagine you just have one single server. Now, App A requires a specific older environment, say Java 8 and Tomcat 9. But over here, you've got App C, and it absolutely needs the much newer Java 17. Because they're forced to share the exact same server space, you get these immediate catastrophic configuration conflicts. If you upgrade to Java 17 for App C, boom, App A instantly breaks. It is a total nightmare to manage.
Which brings us to section 2, the shipping container solution. This standard unit.
So how in the world do we fix this messy dependency nightmare? Well, the answer actually comes straight out of physical history. In fact, this is exactly where Docker gets its name and that iconic little whale logo. Decades ago, the physical shipping industry was a complete mess. Companies shipped stuff in barrels, wooden boxes, weirdly shaped bags, pallets, you name it. And this was horrible for the shipping docks because they needed entirely different machinery for everything. A forklift for this, human labor for that, a custom crane for the barrels. It was terribly inefficient. But then someone had a brilliant idea: standardize it. Put everything into those large steel shipping containers we see today. Suddenly the dock didn't care if you're shipping a barrel of crude oil or a fragile box of flat-screen TVs. Because it was inside a standard box, one universal crane could just pick it up and drop it on a ship. Docker does this exact same thing, just for your software. So what does it really mean when someone says they're going to Dockerize an app? It simply means you take your application, let's say our old friend App A, and you tightly package it up with all of its specific dependencies, its libraries, even its own tiny little operating system, all into one standardized unit, a software container. Once you do that, you don't need to hand configure a server for Java 8 ever again. All you need is a server that has Docker installed on it to act as your universal crane. Docker just picks up your container and runs it perfectly, completely walled off and isolated from everything else on that machine. Moving right along to section 3, images versus containers, static versus running.
Okay, these are easily two of the most confused and misused words in the entire Docker universe. So let's clear up this terminology right now using a simple DVD analogy. The image is exactly like a physical DVD disc. It's static. It's just a package. It holds the video files, the audio tracks, the menu screen, the copyright warnings, all bundled together by the studio. That is your packaged code. But a DVD sitting on your coffee table isn't actually doing anything, right? It only comes to life when you insert it into a player. The container, then, is the DVD player actively playing the movie. It's your application actually running and doing its job. And the beauty is, you can take that one single static DVD image, pop it into 5 different players in 5 completely different houses, and every single one of them will play the exact same movie perfectly.
Let's lock this in with a super simple mantra. You run a container from an image. That's it. An image is just the static package you built, and it magically turns into a container the absolute second you tell Docker to run it. Keep that simple rule in your head, and literally everything else in Docker becomes so much easier to understand.
All right, section 4, Docker's CI/CD superpower, reliable deployments.
Now, CI/CD, continuous integration and continuous deployment, is just a fancy way of describing how code travels from a developer's laptop out to the live public website. Back in the day, a developer might push some new code to the testing server at, say, 1 p.m. Testing takes about 30 minutes. Cool. At 1:30 p.m., it passes and that code is pushed live. But what if another developer accidentally merged a nasty bug into the central repository at 1:15 p.m.?
Suddenly, that totally untested bug slips right into your live production environment. Disaster, right? But watch how Docker completely solves this. With Docker, at 1 p.m., you package your code into an image. You run your tests on that specific, sealed image. And when testing wraps up at 1:30 p.m., you aren't grabbing fresh, potentially changed code. No, you pull that exact same sealed, mathematically identical image and you deploy it. No matter what chaos happened between 1 and 1:30, your deployed app remains flawlessly unchanged.
And here's the second half of that CI/CD superpower. Let's imagine you deploy version 1.3 of your app to production, and yikes, a hidden bug reveals itself. Everything is crashing. Before Docker, reverting that codebase was a terrifying, messy process of undoing code commits while the site was down. But with Docker, reverting a bad deployment is quite literally as simple as swapping out a DVD. You just tell your server, hey, stop playing the broken version 1.3 image, and instantly start playing the version 1.2 image again. Boom. You've reverted your entire infrastructure in seconds. It is pure magic for keeping your software reliable.
But all of this isolation brings up a really important question. If a Docker container is basically its own completely isolated, perfectly sealed little computer running inside your main host computer, how do we actually interact with it? If it's running a web app, how does web traffic even reach it?
Which brings us to our final section, Section 5, Navigating Port Mapping, Getting Inside.
Now, I know port mapping sounds like really intimidating network jargon, but we're going to make it incredibly simple using the apartment analogy. Imagine you want to go visit your friend Bob. First things first, you need his street address, right? Something like 123 Main Street. In computer networking, that is your IP address. It gets you to the correct physical building, or in our world, the correct host server. But once you get to Bob's building, you can't just walk through the brick walls. You need to know which specific apartment unit he lives in. Let's say he's in Unit 8. You have to walk through door number 8. On a server, that specific door is called a port. Every single computer has over 65,000 of these ports, or doors. So to talk to an app, you need the IP address to find the actual machine and the port to knock on the correct door.
So here's how it works with Docker. When you spin up a container, the application running inside that sealed box is listening on a specific internal door. Let's say port 80. The developers who wrote the code hard-coded that. You can't just change what door the app uses on the inside. But as the person controlling the main host server, you control all the outside doors. So you use something called port mapping. You essentially tell Docker, hey, listen to me. If any internet traffic hits my host server on outside door 8080, I want you to instantly map it and funnel it straight through to the container's inside door 80. The left side is your host port. You're the boss of that. The right side is the container port, which the app needs. It's really just connecting an outside door to an inside door. That's it.
Now, to actually put all these concepts into practice, you've got to know a few essential commands. I know Docker has a really nice, slick desktop interface these days, but getting comfortable with the command line is absolutely crucial. When you're out there in the real world dealing with automated CI/CD pipelines or remote Linux servers, you aren't going to have a mouse to click around with. You need to know Docker pull to download your images from the web, Docker run to actually spin them up and bring those containers to life, Docker PS to see exactly what's currently running on your machine, Docker stop to cleanly halt them, and Docker images to see your whole local library of downloaded packages. Mastering just these basic terminal commands gives you total, absolute control over your infrastructure.
Wow, okay, we have covered a lot of ground today. We looked at the absolute chaos of the dependency nightmare. We saw the brilliance of the standardized shipping container fix. We untangled the difference between a static image and a running container, and we learned how port mapping easily connects it all together. You now have the foundational roadmap to navigate what is arguably the most essential technology in modern software. So I want to leave you with this somewhat provocative thought. Now that you truly understand the mechanics and you see the incredible power of total isolation and instant rollbacks, what messy, conflict-ridden legacy application in your own codebase are you going to Dockerize and simplify today? Because trust me, the power to totally clean up your infrastructure is right at your fingertips. Thank you so much for joining this explainer, and hey, happy building!